Hello and welcome to this episode of SPSS one-on-one series with Warrior Analytics. In our previous episode, we had an overview of logistic regression analysis. So today we are starting on the first type of logistic regression analysis, which is binary logistic regression analysis. We are looking at the steps that you have to take when running this analysis. And as usual, we have got 3 steps of a regression analysis. First, you check for the assumptions. Second, you build the model. And third, you do a final model check to see whether it predicts your outcome well. So we shall start with checking for assumptions of binary logistic regression. And here, we are going to look at outliers and how to check for collinearity. Logistic regression analysis is highly sensitive to outliers and collinearity, having a strong correlation amongst the predictors or independent variables. But additionally, we also have other assumptions that we test in binary logistic regression. This includes, you have to ensure that your outcome is binary in nature. You only have 2 groups of outcome. Independence of observations. Shouldn't be working with, say, paired data. You should have sufficient sample size, usually around 40 cases per variable you're going to analyze. And lastly, linearity of log odds. So today we are going to focus on these 2 major assumptions of logistic regression, and that is outliers and collinearity. We are going to use a dataset that comes pre-installed with SPSS called the ADL dataset. I've included a link in the description of this video where you can download this dataset. So in this dataset, it is about characteristics of patients. We have a group, whether treatment or control group, gender. This was about females only, so we are not going to use this variable. We have age, which is continuous, length of hospital stay. We have diabetic status, which is going to be our outcome variable. It is either a yes or a no, so it is a binary outcome. So binary logistic regression applies in this case. We also have other variables like hypertension status. We have atrial fibrillation. We have prior stroke, whether this person is a current smoker or not. And we also have post-stroke depression. We are not going to use these last 3 ordinal variables. So our focus is going to be on these other variables. In this data set, this is our outcome, diabetic mellitus status. You can just run descriptives to see it is frequencies, analyze descriptives, frequencies, and you want to see diabetes mellitus status. Then you will see that we have a total of 100 participants. Those who had diabetes mellitus were 15, and those who did not have were 85. So this is our outcome for this variable. So when testing for these assumptions, we'll start with the collinearity, testing for collinearity using variance inflation factors and tolerance. Collinearity, that is having strong correlations among the independent variables. The strong correlation may influence our analysis, so we have to check this from the start. Now, checking for collinearity in SPSS is not a straightforward procedure, just like we saw in linear regression. This one involves several other steps where you predict something and use it to calculate another thing, and so this is what we mean. When you're checking for collinearity, there are 3 basics that I want us to first remind ourselves. Number 1 is about our linear model. In linear regression, in our previous videos, we saw that our outcome has a linear relationship with our independent variables. a direct linear relationship. But when it comes to the logistic regression model, this is not the case. The outcome does not have a direct linear relationship with the predictors. It is the log odds that have a linear relationship with the predictors. So it means for us to assess for collinearity, we should find a way of fitting a linear model between log odds and the predictors before we can get the collinearity diagnostics. What we mean, in SPSS, we can only estimate or predict the probabilities. Remember, if you have probabilities, you can get odds by getting probability over 1 minus probability. It gives you the odds. Then you get the log of those odds. Once we have those, we can have a linear relationship between log odds and the predictors, which we can now use to assess for collinearity. So this is what we are going to do. We are obtaining probabilities from the binary logistic model. Then we calculate the odds. We calculate the log of those odds. We fit a linear regression model, and then we get the VIFs. So what we are doing is obtaining probabilities. We are going to obtain this P at this step. Then we calculate odds. We put in this formula using the P we've obtained to calculate the odds ratios. Then we apply the log onto what we've calculated. And then in that way, we shall have this whole expression of logit P, and we use it to fit this linear relationship model. This one here, it is from that we shall get the VIFs and the tolerance. So this is simple to do. Let's see how practically it is done. Using our data, the first thing is to fit our binary logistic model. This is, we go to analyze, regression, and then go to binary logistic regression. As you click OK, this is the dependent variable, and we said diabetes mellitus, that is our dependent variable. Then our covariates, we have treatment group up to post-stroke depression here. Remember, we said they are all females, so gender is not changing. Change here under categorical. You have to specify in your variables which one is categorical in nature. So click on categorical. Treatment group has control and treatment, it is categorical. Then these, the last four, are also categorical in nature. So you can just click shift and click on the last one, then push all of them at once. For now, we need to change the reference category. Go to click on first, and then you change. But this depends on your data. You may be interested in using a last category of a variable as the reference. It is okay, you can leave. But if I'm interested in using the first category as a reference, yes, click on this and change. Then you should be able to see that there is first against it after the word indicator for each of those variables. So continue, and then under save, you're going to predict probabilities. So you check on probabilities and you click continue and say OK. So when we check on our data editor, we shall see that there is a new variable that has been added called predicted probability. On our PowerPoint, we have gotten probabilities. Then next we are going to calculate the odds and get the log odds. We are going to combine these two steps into one by calculating the log odds once. Remember we said the formula is probability over 1 minus probability. So if I go to the data editor, we are going to transform, and then you say compute a variable. We are going to compute a new variable based on from these other probabilities, or a variable of probabilities that we've generated. And what we are creating are what we call the log odds. Okay, so that is our target variable. Then in the numeric expression, we are getting the log of odds. So we shall come here under functions. We can click on arithmetic, and then this is the expression for log. This one here, once I click on it, I can use this arrow to move it to the numeric expression box. Then inside here, you can see a question mark. You're getting log of what? So we have to define what we are getting, the logs of what we are obtaining. Okay? So for us, we want to get the log odds, but remember we have probabilities. So inside here, I'm just going to remove this question mark, and I put there the expression of calculating odds. So that is, I will open another bracket, and I say, for you to get odds, it's the same as these probabilities. Okay. Divide by, can use this, divide by, okay, then I open a bracket, divide by, again, now 1 minus, again, probability, that same variable, then I push it there. Okay, so I'm getting the log of these. Yeah, I can now close this bracket. Then click OK. Oh, sorry, I've not added another bracket. Yes, I put excess brackets. Okay. So once you click OK, you should be able to see that in your data set, you've calculated a new variable called log odds. Log odds. So when you look at our PowerPoint, we have obtained probabilities. We've calculated odds using the inside of the bracket, and then we applied log. So we have log odds right now. We have this expression. So now we are going to fit a linear model. This is the step at which we are. So at this step, we are going to fit a linear regression model. Remember, we are in logistic regression, but we are assessing for one of the assumptions, that's collinearity. But to assess for collinearity, we said it is not a straightforward procedure. We have to first get log odds. They are the ones with the linear relationship with our predictors. And once we get those log odds, we fit a linear regression model. It is the one we are going to eventually use to assess for collinearity. So here, we go to analyze, go to regression. We are using linear regression. Okay? Under linear regression, now our outcome is the log odds. We put it under dependent variable, and then we put in all these other variables. If I click on the first one and I hold down the shift button, I click on the last one, all of them will be selected. I take them under independent variables, but remember we said for gender, we are not using it because the data set only has females. Then we can say OK. Now, what we are interested in is not this model, but for us to use this model to estimate collinearity diagnostics. So when we go to analyze regression and then linear regression, we are interested in under statistics. Click on statistics, we are interested in collinearity diagnostics. Select it and then continue. Click OK. And then you're going for this table that has coefficients. Don't mind about this other side. Our interest is in collinearity statistics, that's tolerance, and VIF. We are interested in those not having a value above 10 for variance inflation factors, the VIF, and then this one, none should be less than 0.1. Remember, tolerance is just this value, 1 over this value. 1 over VIF gives you tolerance. Since none of our values is above 10 for VIF, or since none of our values is below 0.1, we do not have collinearity or multicollinearity. Our independent variables do not have strong correlations amongst themselves that would affect our analysis. In that way, we have assessed for collinearity. That's what I was saying, it is not a direct procedure. So now let's turn to how do we check for outliers. Still using our data set. In this case, we are now going back to our logistic regression model. We fit it before we run our outlier check. So we shall have to go to Analyze, Regression, and then you go to Binary Logistic Regression. We already have put their values, okay? We've already defined the categorical ones, so the model is already there. What we need is to go under Save. We are no longer interested in probabilities. And this time round, we want Cook's distance, we want leverage values, and we also want the DF betas. Click Continue, and then click OK. At this point, when you look at our data set, we have got other values predicted. We have Cook's distance here, we have leverage values, and DF betas for each of our variables. We have DF beta for the constant, we have for treatment group, for all the variables that are in our model. Once we've predicted this, we go ahead and summarize them. Go to Analyze, Descriptives, and then Frequencies. I want to reset this. What we are interested in are these, starting from the Cook's distance up to all the DF betas. Put them in, and then we don't want frequency tables, but instead we are interested in minimum and maximum values. Okay, click Continue and then OK. So in this table, I'm interested in the maximum values. So for Cook's distance and leverage values, if I have any with maximum values above 1, it would potentially mean there are outliers. Okay, now in this indicates for us that potentially there are outliers. When you look at the leverage values, there is none above 1. The maximum is 1. Okay, for it says, okay, maybe there is no outlier. Then when you look at the individual DF betas, we are interested in saying none of the DF betas should be above 0.5. But we look at atrial fibrillation, there is one above 0.5. Okay. Then we also have, this is for the constant. This is for the constant. We are focusing on this. So potentially, these ones, the Cook's distance and leverage, is almost at the borderline, showing us that there might be outliers in our data set. And when you look at the DF betas, it is trying to point to us that atrial fibrillation may be having outlier values. So you have to go back to your data set, examine it well to establish whether there are truly outliers in your data set. We've checked for assumptions, collinearity, that one passed. Then for outliers, there was a variable, atrial fibrillation, that was suggesting that there are outliers, but you need to check the details of that variable based on your research study. So far, we've finished the assumptions. In our next video, we are going now to build our model. We are going to build our model, and in this, we are going to select variables for multivariate analysis, check for interaction, and then check for confounding. So don't forget to like, subscribe to our channel so that you do not miss out any of the episodes when they are released. If you have any comment or any concern, feel free to leave it in the comment section. We shall be glad to respond to it. So see you in the next video.